Hi folks, we're going to take a look at page 227, number 25. So they want us to find an exact value of C such that this equation is true. So essentially asking us to solve this equation, but notice that they say find an exact value of C. So that suggests that there might be more than one possible answer. Let's think about how we might solve this. Now, I'm not quite sure how I can really simplify this. I guess I could try to use compound angle formulas for tangent, and then this would be 1 over tangent. But it looks like I would get something extremely complex, something that's probably going to be very difficult to solve for the variable. But the other thing I notice here is I have an equation that has both cotangent and tangent. That actually reminds me of something on our formula sheet. Because if you look at the correlated angle identities, you see 4 equations which have both tan and cotangent. And in fact, what you have is a tangent value equal to a cotangent value, or a tangent one equal to the negative of a cotangent value. And when you take a look at this equation, you realize that you can write it in such a way by bringing one of these terms to the other side. Now, while I'm sure I could solve the equation either way, I might as well try to write it in such a way that it perfectly matches one of these identities. Okay, so I notice here in all these examples, even the ones with the negatives, it's always the tangent value that's positive and the cotangent value that's negative. So what I'm going to do is I'm going to bring the cotangent value to the other side of the equation. Okay, so that gives us tan of 2c plus pi over 4 equal to negative cotangent of 4c minus pi over 4. Okay, so now we have something much more familiar. And since I'm only looking for one of these values, I'm only going to need to use one of these two identities. In fact, maybe what I'll do is I'll actually find two different answers just to see how we can use two different identities to come up with two different answers. Let's start with this one here. So let's write that on the side. We have that tan of pi over 2 plus theta is equal to the negative of the cotangent of theta. Now, what you have to remember about this equation is it's not an equation that you solve. This is an identity, meaning it's true for any value of theta. I can choose theta to be anything I want. In particular, I'm going to choose theta to be equal to the angle inside this cotangent. Okay, I want to match up this equation to my identity perfectly. So what I'm going to do is I'm going to let this angle here, 4c minus pi over 4, be equal to theta. But remember, this equality is always true. So if this angle is equal to theta, that means that this angle here inside the tangent must be equal to pi over 2 plus theta. Okay? And so these two are equal. So that means that 2c plus pi over 4 is going to be equal to pi over 2 plus theta. But wait a minute, what did we say theta was? Theta is 4c minus pi over 4. So I'm just going to substitute that into my equation. And let's see what we're going to get. So 2c plus pi over 4 is equal to, pi over 2 plus theta, which is 4c minus pi over 4. And look what we end up with, an equation with only c in it. Not only is it an equation that only has the variable c, it's a nice, easy linear equation. So yet again, we've managed to take a much more complex equation and turn it into a simpler one, namely here, linear. Okay, so let's recall what we did, is we used the fact that this identity is always true. So I chose theta to be 4c minus pi over 4, the input of cotangent, which is what we have here. So that means that the input of tangent must be equal to pi over 2 plus theta. Okay, I'm using the fact that this relationship is always true. Okay, so let's solve and we'll get one of our answers. So here we'll bring the c's to one side, so 4c minus 2c, so we have 2c. And then here I have pi over 4, okay, minus pi over 2. And then here, this is going to be plus pi over 4 when I bring it to the other side. Okay, and maybe you can already see where this is going. But what do we have? I'll put everything in terms of the same denominator. So pi over 2 is like 2 pi over 4 plus pi over 4. So what do we have? 1 minus 2 is 1, plus 1, hey, that's just equal to 0. So C equal to 0 is one possible answer. Okay? Now, by the way, I think they might ask you to check this. Well, how would you check your solution? Hey, you can just stick this in Desmos. Okay? Stick this equation in Desmos and see if when C is equal to 0, okay, your Y value is equal to 0. Okay? Or you can stick it into an equation calculator to test that this is one of the possible answers. Now, even though they didn't ask us for a second answer, sometimes they do in these questions. Let's see how I would do it to find a second answer. Well, remember that this was not the only identity that has a tangent value equal to the negative cotangent value. This one also does that. So let me now use that second identity and see if we can generate a second answer. So here, we're going to use tan of 3 pi over 2 plus theta. It's also equal to negative cotangent of theta. And I'm going to do the same thing. I'm going to have theta be equal to 4c minus pi over 4. Okay, but in this scenario here, that means that 2c plus 4 pi over 4 has to be equal to 3 pi over 2 plus theta. Okay, so same argument here, that if I choose this angle to be my theta, then this angle must be equal to 3 pi over 2 plus theta. And now I can do the same thing. I just do a quick substitution. And yet again, I end up with a linear equation that I can now solve. All right. So let's do that here. Again, I'll bring the 2c to the right-hand side. So I'm just 4c minus 2c is again 2c. And here, what are we left with? So I'm just going to put everything over 4 as I write it. So I've got pi over 4, which was already on the left-hand side. I'm going to subtract. So 3 pi over 2. This is going to be 6 pi over 4. And then here, this is going to be plus pi over 4. So what do we have? We have 1 minus 6 is negative 5, plus 1 is negative 4. So negative 4 pi over 4. Hey, but this, 4's cancel out. So negative pi equals 2c. So c is equal to negative pi over 2. And that would be a second answer. Whoops, there you go. That would be a second answer to this equation. Okay. Now, if you were to plot this on Desmos, or you were to put this into an equation calculator, you would actually find that there's not just two answers, there's actually infinitely many answers to this equation. And that's not something that should surprise us, since we're dealing with trigonometric ratios. Okay, so again, here's the full solution, and that's it for this one.